Hello. On students' request, I will give a revision of 1 1 and 1 1 and on to functions. These we call types of functions. First, we will go for injective function. Injective function are 1 1. Let's consider this set A and this set B. And there is some function f defined from set A to set B. Here are A, B, C. Let's say here is 1, 2, 3, 5. If every element of set A, this should be every element from set A should be related to some element here because it is a function. A, B. Let's consider this was F1. This is F2. Obviously, need not to have same domain and range. B, C, 1, 2. Now these consider these two functions. First F1 from set A to set B. Second from first set A to set B. Let's say here was 3. In first example, we have every element of A as distinct image in set B. A has distinct. If we take A and B, A is not equal to B. A is not equal to B. A is different. B is different. A is not equal to B. This is giving us f of A1. F of A1. F of A1 is 1. F of B1. What is f of B1? F of B. Sorry, not A1. A. This is f of A. F of A is 1. And what about f of B? F of B is 2. If I take any two elements from the domain of the function f1 and finding its images in the set B. If I get f of A not equal to f of B for all A comma B belonging to A domain, then I will say f is 1 1 or injective. This should hold for every element of set A. On other side, the converse of this is if I take f of A, if I take x1 equal to f of A equal to f of B, this should imply conversely. This should imply A equals to. If there are two images in the codomain set, there are two images in the codomain set are two elements. I have taken two different things here, two images here and equate them. If they give me that these elements from the domain set are also equal for all a comma b. Then I will say f is 1 1. This is converse of this. Okay. In second, if I take here examples, I will go to the next page. A little bit the right here. Second example is this is F2 and this is B. Here A, B, C. 1, 2, 3. A is going to 1, B is going to 1, and C is going to 2. Take here A, comma B. A is not equal to B. Clearly A is not equal to B. Now check what is f of A. F of A is equal to 1. What about f of B? F of B equals f of A equals to 1, f of B also equals to 1. For A not equal to B, here for 1 1, checking for 1 1, f of A should not equal to f of B. Here what we got, f of A equals to f of B. So it does not hold our definition. This function f is not 1. Is this clear? I will write the definition. Definition for 1 1. If each element in the domain or of the domain of function has distinct image in codomain. The function is known as 1 1 function. And we can say 1 1 function is also known as injective function. If every element from set A to set B in this each element has distinct image. That means A has different image, B the second element has distinct, this third element has distinct. Then we call it as 1 1 function. Is this clear? Consider this function f of x equal to 2x plus 1. Now we want to check this function if this 1 1 are on 1 1 are not. What we will take? We will take that x1 comma x2. These are not equal. Take, let's say, 1 and take 2. These are not equal. This should imply f of x1 should not equal to f of x2. What will be f of 1? F of 1 will be 3. F of 2, f of 2 is 5. F of 1 is not equal to f of 2. This implies f of 1 is not equal to f of. We took 1 and 2 and we got they are not equal. We got f of 1 not equal to f of 2. Similarly, if we take any x1 which is not equal to x2, x1 not equal to x2, take any x1 not equal to x2. These functions are defined from R to R. If there is not anything given, they are defined from R to R. Okay. We got f of x1 not equal to f of x2. So this is 1 1. Otherwise, what we can do, we will go for reverse. There is, I will write a note. Note. P implies Q. By definition, not P implies not. This is not. Not Q implies not. This P implies Q means not Q implies not P. P implies Q by definition, not Q implies. You have to remember this. Same we will use here. We were using definition x1 not equal to x2 should imply f of x1 not equal to f of x2. Now, in return, what we will say here it is f of x1 not equal to f of x2. We will write if f of x1 equals to f of x2, this should imply x1 equals to x2. Got this?
So,
So our function was f of x was 2x plus 1. Consider f of x equals to f of x2. We are taking here arbitrary x and x1 and x2. This should give us x1 equals to x2 for all x1 x2 belonging to domain which is R. Here we have function f of x equal to twice x plus 1. We'll use this definition f of x1 equals to f of x2. This should imply x1 equals to x2 for all x1 comma x2 belongs to domain of the function f of x. Domain of function is R, set of real numbers. Let's consider this f of x1. F of x1 will be twice x1 plus 1 and f of x2 will be twice x2 plus 1. Now can I cancel this one and this one? Yes, twice x1 equals to twice x2. Now dividing both sides by 2, we get x1 equals to x2. Since x1 and x2 are arbitrary, we can say f is 1 1 or injective. Isn't this so simple? Similarly, if you have given any function, you can easily check if it is a 1 1 or not. Okay, let me go to the next page. If you want to write, you can write this also. Now we have methods. We have three. We are using three methods. First is analytical method, which we just defined. X1 not equal to x2 should imply f of x1 not equal to f of x2. Or if f of x1 equals to f of x2, that should give us x1 equals to x2. Methods to determine one one function. First method, analytical method. Let x1 comma x2 belongs to domain of f. If f of x1 comma x2 are the points in domain, this is b, this is a, this is f. This is domain x1 comma x2 belong here. And if x1 is not equal to x2, these are different points in the domain of our function, implies f of x1 not equal to f of x2. Obviously, there will be some image here. This will be f of x1 and this will be f of x2. Operating function, then here it is f of x1, here it's f of x2. If x1 not equal to x2, implies f of x1 not equal to f of x2 for every x1 comma x2 in the domain. These x1 and x2 are in the domain. That's why I have written here for every x1 comma x2 in the domain. We will check every element here. Let's say it is x3. We will check that element also. If this definition hold x1, if I take any x1, x2, let's say it's not first element, it's second element, it's third element, it's any element. These are two different elements from the domain of the set, and we are checking if their functional value which is f of x1 and f of x2. These are two different elements, their images are different. If this holds for every element in the domain, two different elements, then we say f is 1 1 function. Then f is 1 1 function. If this doesn't hold, then we will say it's not one function. If it is not one, it's money one.
Sir,
Or we can say conversely, if f of x1 equals to f of x2.
sir,
Huh. Yes, any doubts? Ask. Yes, Kailash. Ask.
give example, sir.
Example?
Yes,
You
sir.
need example.
Yes, sir.
Okay. Okay, let me finish the definition, then we will give examples. Okay. Conversely, we either we can use that or we can use this. If f of x1 equals to f of x2 implies x1 equals to x2 for every x1 comma x2 in the domain. In the domain, then f is 1. Else minimum. And you can write note here. A function is either 1 or minimum. A function can be 1. If it is not 1, it's minimum. Is this clear? Okay, example, we can try examples here. Example 1, f from R to R, f of x equals to sin x. How will we check? Let's say f of x equal to f of x2. Then sin x1 equals to sin x2. Now this x1 and x2 should be only one element, but we will get here x1 equals to 2n pi plus minus 1 to the power n x2, these many elements. Our second thing is take two different elements in this set. I will take I will take 0, I will take pi.
Sir,
0 and pi are different elements in this set, but sine
sir,
0 equals to 0 and sine pi equals to also 0. Hmm. Is there any doubt? Ask.
here x is equal to not 2 n pi, sir. Only n
Huh?
pi.
Can you say little loud? I am not able to hear you. Hello. Okay, you have written something. N pi only. No, no, no. Okay, I will show you how this is equal to this. To n pi. This is sin x1 equals to sin x2. Oh, you are saying this to n pi. Okay, okay. It will be n pi. Okay. Because n pi, obviously, there it is 0. N pi, then plus this x, 1 equals to x at that point. Hey, see, sin x1 equals to sin x2. Can I shift this sin x2 here? This is sin x1 minus sin x2 equals to 0. Can I write this? And now I will solve this when it's equal to 0. How I will solve this? Sin c minus sin b. This is equal to y cos c plus d by 2 into sin c minus d by 2. Then it will become twice sin. Now I have to solve if this function is equal to 0. This was our 0. This is our 0. Now either when is cos x equal to 0 and when is sin x equals to 0. Here c and d is x1 minus x2. X1 plus x2 divided by 2 equals to 0 and x1 minus x2 divided by 2 equals to 0. I have to solve this. But this should be in sine. When sine is 0, n pi. And when cos is 0, 2n plus 1 pi by 2. Sine is 0 at 0, then pi, then 2 pi, then 3 pi, n pi. Okay. When it's in sine, then we have n pi. When it is cos, then we have this. This is pi 0 is cos n pi plus pi by 2. That we can write 2n pi plus 1 pi by 2. So we have to solve this and we will get this expression. X1 equals to n pi plus minus 1 to the power n into x2. You can try it on your own. Is this clear? Now what we will do, if we have two more methods. Second is method 2, graphical method. Graphical method says draw the graph of the function if there exists if there exists at least one line parallel to x-axis. If there exists at least one line which is parallel to x-axis and touches the graph at more than one point. Then we say f is many one. More than one point means 2 points, 3 points, 4 points, at least one line. If there is no line which touches a graph more than one point, then we say it's one. Take this example. Let's say this is y equal to x square. We will draw this line x equal to 2. It touches our graph at more than one point. Then it is f is many one. If it is not many one, then it's one. Let's say take this y equal to x cube. Draw any line. No line will touch our graph at more than one point. So it is not many one. If it is not many one, it's one. F is one. Let's go to the next page. Is this clear graphical approach? Just draw the thumbs up. Okay. F of x equal to twice x plus 3. This is our function. We can draw the graph of this function. How is its graph? Twice x plus 3. So it will shift towards left here. Here it is 3 by 2. Let's say this is 1, this is 3 by 2. So it will be this. Draw any line which is parallel to x-axis. Any line which is parallel to x-axis. How many points it will join? Only one. At max 1. So f is 1. F is not many one, obviously it's 1. And third method is differentiation by differentiation method. In this case, our function should be continuous. Let's say our function is continuous. Then we can do its derivative. We can find its derivative if that derivative is either greater than f dash x is greater than equal to 0 or f dash x is less than equal to 0 for all x belonging to domain of the definition. Then we will say, in that case, we will say f is 1 1. Why? Because it is strictly increasing or strictly decreasing. It means either function is going like this or function is going like this. So no, if we draw any line, or it can be like this also. Okay, this will not be. Otherwise, like this. So no line will touch my graph at more than one point. So it is clearly 1 1. Okay, I will write the definition. Let f of x be the continuous function and derivative of function is greater than equal to 0 and less than equal to 0 for all x belonging to domain of definition. let f of x be continuous function and derivative f dash x is greater than equal to 0 or f dash x. F dash x means derivative, okay, is less than equal to 0 for all x belongs to domain of definition, D of f or domain you can say. Then f is 1 1.
Sir,
Uh, and here we should note, it should be noted that the value of x for which f of x equal to 0 should not form an interval. Here the note is the values of f at which the values of x at which f of x equal to 0 should not form an interval. F dash x. We are finding f dash x. This should not form an interval. Okay. And if there are some functions which are not continuous, do not apply it there. There, it like f of x equals to tan x. What is f dash x? Sec square x. This is always greater than equal to 0. Sec square x is always greater than equal to 0. But if you check tan function, it's not defined at n pi plus pi by 2 plus minus pi by 2. Here it is not defined minus pi by 2, pi by 2. Then this is pi. It is not defined at x equal to pi. It's discontinuous. So in this case, we will not apply these. Okay, we have to be very cautious in these cases. Or you can check tan x cot x also. Cot x is not continuous at where cos this sin x equal to 0 and pi. So is this clear? Okay, let's consider this
yes,
function f of x equal to x cube plus x plus 1. Sir, let us give some examples other than trigonometry that violates f of x equal to 0 or f of x less than equal to 0. Give me some examples other than trigonometry and that violates f of x equal to.
sir.
Ah, here if we write the polynomial function which violates the this, then we have to make it stepwise function. Then it will definitely violate. If we write like this, these type of functions are obviously continuous, so they will not violate. Either you have to make it this p by q rational function, or we have to make it piecewise function. If I write like, let's say, x square x uh, x cube x is greater than equal to x is greater than equal to 1, and x, let's say 2, x 0 less than equal to x less than 1, and x cube 0 less than x less than x less than 0, x is less than 0. Now try to see this will, what will be this f dash x, this is 3x square, this is greater than 0 on this interval. What about this? This is 0, f dash x equals to 0 on this interval, 0 less than x less than 1. And what about this? This is, otherwise I can write here minus 2 also. Not the case. F dash x equals to 3x 3x. Okay. This is also greater than equal to 0. This is also greater than equal to 0. This is also greater than equal to 0. But this f dash x is greater than equal to 0 for this interval 0 to 1. If you check, so here, if I draw the graph, after 1, it is behaving like this. And what about this? Uh, Less than 0, it's behaving like this. What about this? Here it is minus 2. Or let's say I had made it 2. Or I have made it 0. Is this 1 1? No. F of 0 goes to, let's say this is 0 only. You can also take 0. You can take also 1. You can take any constant function here. F of 0 equals to 0. F of 1 goes to 0 also. Okay, less than equal to. F of 1 by 2, 1 by 3, 1 by 4, f of 1 by 100, these all go to 0. This violates the definition for this. See, f dash x greater than equal to 0, f dash x greater than equal to 0, f dash x greater than equal to 0. So for all x, f dash x is greater than equal to 0. But the problem is this interval f dash x equals to 0 on this interval. Is this clear? I hope you got the example what you were asking. If we try to find out this polynomial, I know all polynomials are continuous, so I will not get here. It is very difficult. Otherwise, it should be on some interval. It should be 0, so it should be only piecewise in polynomial function. Okay. Now I have written some function. Okay. Let's consider f of x equal to 2x square. What is f of x1? 2x1 square. What is f of x2? 2x2 square. Solve for this, f of x1 equal to f of x2. So 2x1 square equals to 2x2 square. x1 square equals to x2 square. This can be x1 equals to plus minus x2 or x2 equals to plus minus x1. So it is not 1. Is this clear? Or you can draw the graph of this. It is like this. So I draw one parallel line, which is I draw these lines first. Then I took one line above x-axis and it touched my graph at 2 points. So my function is not 1. Or f dash x third test is 4x. Now this is not always greater than equal to 0. If I take f of minus 1, this will be minus 4. If I take f of 0, it is 0. If I take f dash, sorry, f dash 1, which is 4. On some interval it is less than 0. Some interval it's greater than 0. So this is not one function. Is this clear? All three methods are clear on this function. Okay, try as many examples on your own and find. That's then it will be easier for you. One is very easy. We have three methods. Check whichever. Even if single method is you are able to apply only one method, that's enough. Okay. Just what there are many questions. If you try to solve 3, 4, 5 questions more, then you will get better understanding on this. Let's consider this function. Okay, try this function on your own. X cube plus x plus 1. Example 1. Example 2. F of x equals to. These are from R to R. Okay. F of x equals to x square plus 4x plus 7 divided by x square plus x plus 1. Check if they are 1 1 or not. Example 3. X square divided by 1 plus x. And check on which domain it's 1 1. F of x equals to mod x. Example 5. F of x equals to x mod x.
Sir,
X cube x to the power 4 1 upon x 1 upon x square e to the power x e to the power x square. Try these functions on your own.
sir,
Base you can change base also. Just ask whatever your doubts. Do for x cube. X cube, yeah. I have already done. Okay. Okay, I will do x cube here only. Okay. See, Let's draw x cube. All three methods we will define. Don't worry. F of x equal to x cube. Let's say f of x1 equal to f of x2. x1 cube equals to x2 cube. This will definitely imply x1 equals to x2. Why? That you have to find answer. Second method, f dash x equals to 3x square. This is always greater than equal to 0. X square is always greater than equal to 0. 3x square is always greater than equal to 0. So f is 1, 1. Third method, this is differentiation method. Third method is drawing its graph. I have drawn its graph. Take any parallel line towards x-axis. This is touching at max one point of the graph. So f is not many one, f is 1, 1. F is 1, 1. F is 1, 1. Okay? Is this clear? I have done all three methods.
Sir, it is on to.
Huh?
Is it on to function?
Sorry? Can you speak little bit loud? Is this clear what I is it on to function? Yeah, we for on to function we will check. For on to function we have to check two things. Its range should be equal to r. If we are defined for on to functions, we have two things. First, check it for check it for if its range is equal to codomain set. Clearly, its range is equal to c. It's this function as x goes to minus infinity, f of x goes to minus infinity. As x goes to plus infinity, f of x goes to plus infinity. So its range is equals to r. Range equal to codomain implies f is on to. Okay. Or you can write y equals to x cube. Now write this in the form of it will be cube root of y. This function is defined for all real numbers. Is this clear? This cube root function is defined for all values of y. So for all y in this codomain, this is r, this is r, and this is f. For this function, for every y, there is some x in the domain. For every y, there is some x in the domain. So it's on. This is cube root. Okay, cube root, fifth root, seventh root. These are defined for all real values of inside function. If it is square root, it's not defined. Fourth root, not defined for some values. Both methods I have shown that it is onto function. Is this clear? Is any other doubt there? Okay, good. Okay, see you tomorrow then. Tomorrow's lecture. We can do detailed analysis on onto functions tomorrow. Okay, don't worry. I will be with you only. Whatever your concern, we can do together. It's not only on your shoulders; it's on me also. And that's it. Okay, see you tomorrow. Bye bye. Happy Ganesha.
ये भाग गया